Hi, Tom. How's it going? Are you ready for the Gestalt IT rundown today?
I am ready, willing, and able, Rich.
I love it. It refreshes my soul to hear that. So we will get going right now and talking about some IT tech news. Hello, all, and welcome to the Gestalt IT rundown, your weekly look at the IT news of the week. I'm your host, Rich Stroffolino. I'm an editor with Gestalt IT. Joining me from across this great nation of ours, indeed, in the panhandle of my heart, it's the one, the only, Tom Hollingsworth. Tom, welcome to the show.
Thanks for having me on, Rich. We need to finish this up pretty quickly. I need to head down to IHOP because it's National Senior Citizens Day, and I need me a $5 Rudy Tooty Fresh and Fruity at 3 in the afternoon before my nap.
Living the dream life. And so is a company I think we're all familiar with. VMware has had what I'm calling acquisition palooza, insert firework effect from Microsoft Solitaire. Um, Lots and lots of interesting news here. We're going to start out, though, with one that is almost an acquisition by all accounts, and that's that VMware is talking with Pivotal. TechCrunch reported last week that VMware is in talks to acquire Pivotal, the company behind Cloud Foundry, or the commercialization of the open source Cloud Foundry platform. If we want to get technical. Pivotal only recently went public a little over a year ago after being spun out from VMware and EMC back in 2012. This all gets weird because Dell EMC owns a majority of VMware and Pivotal, with VMware itself holding a significant interest in Pivotal. So if they get acquired, then Dell EMC kind of whatever. It's a very weird relationship between them all. At the end of the day, though, Cloud Foundry is almost a de facto standard in the Fortune 500 when it comes to software development as a platform. Does this make sense for VMware here, Tom?
The last time I tried to sort out one of these big acquisition chains like this, I think I ended up becoming my own grandfather through time travel. Like it's just crazy. But this is when you look at all the moves that VMware has been making over the last I don't know year. They've been cozying up to cloud providers. AWS, Azure. Not Google because I don't care about Google and Oracle Cloud. Insert joke here. The thing
Be
is
nice, Tom.
VMware.
Be nice.
I'm being nice. I didn't say the L word. Um, Cloud is an existential threat to VMware. Let's call it as it is. If people adopt AWS and Azure with lock-in, they're not going to care about VMware anymore. So VMware has to have some kind of an offering, even if it's like a boutique cloud. And that's what Pivotal gives them. And the irony is that they were so intent on spinning all this stuff out, 7 years ago, because there's no future in cloud. Nobody cares about cloud. And
You
now they're
fool.
running back. They're like, please take me back. I'll do the dishes. We'll go out on dates more often. Just please, we need you. We need you. The cats are getting lonely. That kind of stuff.
So just to really like in your mind, this is part of a grander vision, just to kind of serve as the whatever cloud you're using, just this cross set of tools that can work across there. Whether you're talking about virtualization, container management,
Yeah.
network monitoring, that kind of stuff.
Yeah, I think that they're trying to use the work that Pivotal's already done to build on where cloud's going next. With things like containers and microservices and that kind of stuff. Because honestly, when you get VMware's stuck in the log jam, you know, whenever it whatever it looks like a duck and walks like a duck and quacks like a duck, VMware's going to call it a virtual machine. And if they don't get past that, I heard a great story on NPR yesterday about the fact that Eastman Kodak was hung up for years on this idea of using film. Why? Because it made them money, and if they had embraced what customers wanted earlier, which in this case would be containers instead of VMs, they could have led the digital photography transformation. VMware still hung up on this idea of VMs, and I think Pivotal is going to be the way that they get kicked off of it.
That's really interesting. Now, the one thing that I haven't heard anything about is if there's any interest from anyone else to buy Pivotal, and does that get into like some weirdness because they're majority owned by Dell EMC? Does that get into weird territory of like, well, who else could buy them but essentially Dell or VMware?
Who else would want them at this point?
Well,
And
is there
ultimately, I think
would there
that's
be value in a company not letting VMware buy them?
no. And the problem is there's so much stuff that you'd have to unwind from all of that mess that you'd spend more money acquiring them than they were worth to you at this time. I mean, if I wanted to spend, I don't know, $800 million on Pivotal, I'd just go sink $800 million into Amazon Web Services instances and get exactly the same thing and be able to
Mhm.
run them for like what, 15 months or something? Spot pricing,
Something like
21
that.
months.
All right. Well, going on with the VMware acquisition of Palooza, I messed up my own portmanteau there. In an actual acquisition news, VMware confirmed the acquisition of Intrinsic, formerly known as Gitstar, although I don't know anybody that's holding onto that name, and Veriflow. Veriflow offers their continuous network verification in and across clouds, on-prem for that matter, which will be integrated into vRealize Network Insight. Intrinsic, meanwhile, offers an interesting tool for VMware's cloud portfolio, focusing on serverless security, effectively allowing serving as a policy management layer for deploying serverless instances across all major public clouds, or using serverless functions, I should say. This joins Bitnami as a major VMware acquisition in 2019. If the pivotal deal goes through here, Tom, which of these ends up being the most important long term, and does this signal anything about VMware's overall strategy?
So it's tough because it feels like Intrinsic is kind of basically waiting on the Pivotal acquisition.
Okay.
Um, so I don't know. I actually have a lot of experience with Veriflow. I mean, they presented at Networking Field Day 16 a couple of years ago. Brighton Gottfried came out of that same group of people as Martin Casado, Nick McEwen, and that whole crew from Stanford.
Hmm.
Um, I think that has a longer term play when it gets integrated into NSX, because network assurance is a huge deal. Let's build a mathematical model of the network and make sure that everything works the way that it's supposed to and nothing breaks and everybody's happy. But the problem is that when you get down to it, networking is anything more than a utility is kind of shot. Cloud is probably where your future is, and it pains me to say that because I am the networking nerd. But you could. I think of it like the electric company. Whether you're on PG&E or OG&E or EGG or whoever it is, you can spend billions of dollars every year in investing in something that nobody sees or cares about. And but that's what you want. You want the network to stay up. You want the utility system to stay up. Whereas the cloud stuff is hot and fresh, and even if people aren't paying as much attention to it, they like seeing all the cool stuff you're doing with it.
Yeah, and this kind of idea of using formal verification, obviously, that's not just a, as you kind of mentioned, Tom, that's not just a Veriflow thing. And interesting, we're seeing people kind of stock up on that IP through acquisitions
Hmm.
now going forward, kind of signaling that it is a larger trend. Admittedly, yeah, one that the whole idea, yeah, to build that in so it's never noticed because you are doing that verification, and then theoretically stuff doesn't go down. Very interesting. I actually I'm most interested to see what, if anything, they do with Bitnami. I know they're kind of saying, I know that, and I know that's the oldest acquisition here, but I know they've kind of publicly said they're going to keep that a little bit more hands off, because that is
Hmm.
such kind of a developer darling, which makes a lot of sense. But I'm interested to see if that is, over the long term, expands them into new businesses that you wouldn't, new kind of customers that maybe VMware wouldn't be associated with generally.
Yeah.
All right, Tom, let's talk about some chips. I'm all about the chips. I love a good chip story, and we had three really cool ones. We'll get the weirdest one out of the way first because it's just glorious. Startup Sarabus Systems, and I don't know if I'm saying that correctly, unveiled its wafer scale engine, the world's largest semiconductor chip. The chip has 1.2 trillion transistors with 400,000 cores and 18 gigabytes of SRAM memory. I'm assuming that's for caching and stuff like that. Um, it takes up roughly an entire 12-inch 12-inch radius silicon wafer. So instead of making a wafer and you chop it up and you make your quad cores and your 8 cores and your dual core stuff, they just make one chip out of it because why not? The chip was made in partnership with TSMC, although Sarabas is evidently very cagey about what they actually let them touch, and includes numerous redundant circuits to help improve yields, which is something I was very curious about because that's the reason we have dual core chips when they're making 8 core chips, is because you can use all the failed 8 cores to make a whole bunch of other dual cores. The chip will be sold as part of an overall compute appliance. You're not going to be buying just this chip in and of itself, made by Sarabas for machine learning and AI workloads. That's really their overall pitch with this. It includes water cooling because it generates 15 kilowatts of power for a chip. Admittedly, I did the math with 400,000 cores. It's actually very low per core. And I want to put core in quotes because again, this is like AI, machine learning kind of stuff. So it's more akin to what NVIDIA does with their Volta GPUs or their Volta accelerators for machine learning. Those aren't proper cores. Those are like, I don't know, accelerator engine, tiny little bits, but it's still a ton of them on a single chip. Their first production systems are expected to ship to customers in September. So, Tom, making a whole chip out of a wafer, is this a thing now? Are we ever going to see this have a meaningful impact? And is AI the only instance where we're going to need like such a high density, just giant, big old chip?
I don't know what these people are thinking. And there's two reasons for that. One, why would you build one big chip when you can just slave a whole bunch of GPUs together? Or something like that. I mean, the resources exist to do this at scale beyond a 12-inch silicon wafer. But more importantly, and this is kind of something that comes up quite frequently in the chip manufacturing business. I actually had the fortune to hear a great talk about doing chip manufacturing from Peter Jones and Dave Zaks at Cisco. You know why we make chips on a 12-inch silicon disk? Because for the same reason that you get one of those salty hint of lime Tostitos and you dip it in the salsa and you're about ready to eat it. And when you pull it up, there's a hairline fracture in the chip and it just falls down into your salsa. And now suddenly you don't have a chip or salsa and you're disappointed. You have all kinds of defects on these silicon wafers. And so when you divide them up and you build out, let's just make the numbers easy. Let's say there are 10 chips on one of those huge wafers, which is a horrible yield when you think about it. Let's just say that one of them has a defect in it. Well, you toss the chip that you built on top of the silicon wafer defect, and you have 9 chips that you can sell. But if you built one chip out of one silicon wafer disk and it has a defect that cripples, like, I don't know, 100 or 1,000 of these cores, are you going to sell somebody a chip that has 1,000 of their cores disabled? I mean, Intel tried that years ago with the 486SX processors. They just basically grabbed the ones off the line that had busted coprocessors and turned them into a market, but
Yay.
not today. 400,000 chips is what I'm buying, not 390,000 chips and a big section of a wafer with a big X through it that says do not use.
Well, and then the other thing is also, with the process of binning, it's not just like failed, chips that like failed part of the manufacturing process. There's also like a huge variance in the frequencies that those will allow,
Mm-hmm.
even on a fully functional chip, which is why you have some chips that are clocked at 4 gigahertz and some that are, clocked at 2 gigahertz, because there is that huge variance in between these individual yields. So again, they're making this as a very, like, clearly making this a very bespoke. This is going this very specific appliance. It's for this very specific use case. So maybe having that kind of specificity, they don't need to make it as general purpose, and that has some benefits to the manufacturing process. But again, it's still like this weird metallurgy of silicon that we have to deal with that has some unavoidable flaws. The other thing that I'm fascinated by, like I want to learn more about this because I just don't know how it could possibly work, is how do you feed all of those cores from system memory? Like that was like a huge problem with AMD's EPYC platform and originally, because it had this asymmetric memory processor, because we're just basically grafting a bunch of quad core GPUs onto a single die, but treating it like it was a multi-socket server essentially within that one die. And there was some performance penalties because they just couldn't feed it memory in the most efficient way because they wanted to have so many cores. Now, I admit, like, maybe latency when you're dealing with training an AI set, like, isn't the most important thing. At the end of the day, it doesn't need to be a symmetrical workload necessarily. It just needs to get done. And maybe this is very optimized for that. Even still, I wanted, like, how many channels of memory do you need to feed 400,000 of these? Again, if they hadn't invested, theoretically, I'm assuming tens of millions of dollars to develop this, if not more, it seems like it's just like hey, we did this. This is cool, right?
Yeah. Yeah. That's what this feels like, is like, hey, we built this really awesome chip. We really hope that people buy like 8 of them.
Please, please. Well, and what I'm assuming the cost of this will have to be astronomical. Now, they weren't ready to cite any performance figures because I'm assuming this barely works at all. Like they've gotten it to the point where it's like technically it works, so they can announce it, and they're going to be trying to like fully commercialize it for a long time. Maybe the performance is in a play, performance per dollar, performance per watt, or whatever. They can make some kind of play where for people that have these very large scale AI workload needs, it makes sense for those 3 customers. But
Yeah.
I'm extremely skeptical. What I am not extremely skeptical, though, is in other AI chip news at the Hot Chips conference, which you guys, we need a better conference name. Intel unveiled 2 Nirvana neural network processors designed to accelerate training and inferencing of AI models. Yes, Tom, you're feeling it. You're in your place of serenity. Developed in partnership with Baidu, the Nirvana neural network processor for training is designed to handle data from a wide variety of deep learning models like Baidu's Paddle, Facebook's PyTorch, and Google's TensorFlow, with 24 tensor processors per chip capable of 119 tera operations per second. That's not terror, that's tera as in the prefix for like storage for metric stuff. The Nirvana neural network processor for inference is designed for getting insights from those trained data sets. It's essentially designed for inferencing, if you know what that is in AI. It offers scalable power, which I think is very interesting, from 10 to 50 watts per chip and up to 4.8 tera operations per second per watt. So I think that's very interesting in that you can scale the power that you need with the performance that you need. It's very interesting. In terms of what that can do, I know those operations per second, like what does that mean for AI? So at this inferencing chip can process 360 images per second per watt in an image recognition model, to give you some basis for that. And Reuters reports that Facebook is already using the new processor. So Intel kind of now, and the back end of all of this is at the core. This is all based on 10 nanometer Ice Lake Intel x86 stuff. It's just highly, highly specialized into this AI machine learning workspace. So, Tom, is this where we're going to see increasingly Intel making its plays here with these kind of, this is their second generation Nirvana chips, but this seems like their first real serious stab at this market.
Yeah, this is kind of, the counterpoint to what we were just talking about. Build a big die with a whole bunch of cores on it. Intel's like, no, we're going to do what we do best, which is make a whole bunch of chips that have really good performance on small nanometer process, and we'll back it with the AI ML stuff that everybody really wants. I mean, when you look at the names that are on there, TensorFlow and the stuff that Baidu is doing, that's really what this is designed for. And Intel realizes where that market's going. I mean, there's only so many desktops that you can sell. There's only so many laptops that you can sell. But if you can sell into these AI workloads, I mean, right now the use of AI and ML is just skyrocketing. And once it becomes self-aware, Intel will be the only surviving humans left, because they'll be the only people with the smarts to feed the need for this thing to replicate.
Well, and it's interesting though that some other companies have made a lot of noise about developing their own inferencing or training chips and that kind of stuff. Tesla and Google with their their TPUs, their tensor processing units. It's interesting that they very intentionally have made this applicable to a wide variety of models. And I think
Mhm.
it's less of a play to maybe go after the hyperscalers because, like I said, Google's already kind of invested into their own silicon. I imagine I'm not 100% if Amazon has made that play yet, but I wouldn't be surprised if they do. But going after companies like Facebook, going after these still large companies that maybe aren't operating quite at that public cloud level, and having something that they can use. I mean, obviously Baidu is a huge potential customer as well, and trying to be, again, maybe being the general purpose hyper specified AI training. Not being general purpose in terms of the silicon design, general purpose into the workloads that you can feed into it.
Yeah, and that's Intel's bread and butter is, when you look all the way back to the 8086, they weren't trying to make a hyper specific chip for a specific processing utilization. They made a general purpose processor. So that's where their expertise is. And I think it's going to pay off for them here.
Yeah, and probably where philosophically is close to what they're comfortable operating with. The only thing better than AI chip news, Tom, is open source chip news, and IBM is moving its OpenPower Foundation under the auspices of the Linux Foundation. So OpenPower was already kind of open source ish, but now they're really open sourcing a lot of different components as part of this move. This means that the power instruction set architecture, to what power would be the equivalent of x86, that instruction set will be open sourced, removing the expensive licensing that the Open Power Foundation previously required to implement the technology. Along with the ISA, IBM will be releasing reference guides for embedding the instruction set on non-open power chips with royalty-free patent rights as well. So not just giving you the right to use it, but giving you the IP around that, which is super important. The underlying technical architecture of OpenPower chips, however, will still remain under OpenPower Foundation license, but being able to put it on non-power chips opens up a whole door. Is this a sign that OpenPower is actually dead, Tom, or do you see this having some benefit of open sourcing this?
I think the benefit is that people are actually going to look at it now. This is something that came up a lot with things like OpenSwitch and some other things that were kind of spearheaded by a company.
Mhm.
But oh well, we'll make it open source so you guys can play around with it. Well, the problem is that when it's open source but heavily sponsored by a specific company, the people who are using it in the market look up and go, well, I'm not giving those people my hard-earned efforts and things like that, because they're just going to turn right around and consume it and use it in their product lines. So by giving it to the Linux Foundation, by moving it out from under their auspices, there's at least the hint that they are looking out for the protocols and the architecture itself. Now, nothing's stopping IBM from going back and taking some of the best contributions and rolling it into the commercial side of things, or trying to improve on the stuff that they keep kind of close to the vest. Because there's one thing that IBM still cares about, it's chip design, which is why this whole thing kind of stayed under OpenPower Foundation for the design aspects. But I don't know. I'm kind of hot and cold on this, because I love the fact that they're contributing to open source. I love the fact that they're giving the project to the community. But I also kind of feel like that this is like, all right, you're moving off to college, and your life's going to be different. And we still love you, but we're changing the locks and we're turning your room into a sewing room.
Yeah, I mean, I hadn't even thought about that, of this kind of being a fishing expedition by IBM to be like, hey, yeah, please put this on some non-power chips. Oh, you found some cool things that you can do with that. That's open source now. All of a sudden we can make some money off of that. That's very interesting. What I really want is for someone to make the most bizarre PowerPC based Hackintosh based on some weird custom bespoke open power chips. That'll never happen. We're like, what, 15 years removed from that ever being possible? But that's where my heart went as soon as I saw this news. I mean, more open source hardware. I wonder if I brought up the comparison of x86 just for comparison, but I wonder if if Intel is increasingly getting into these specialized market, x86 becomes less relevant over time. If we'll ever get to that point with Intel, who knows? But that would be probably not. Tom's shaking his head, but that would be
No
awesome.
way.
More open hardware is better hardware for me. So at least I'm encouraged about that. Also, weird to say open source and IBM still, even though I know they're a huge open source provider. That just about brings us to the end of the show. Chips and acquisitions. What could be better, Tom? Where can people find more of your great stuff if they are so inclined?
I am all over the place. So I am on Twitter at Networking Nerd. My blog is networkingnerd.net. I've got a lot of great content that's been coming out on gestaltit.com as of late. Some of the events that I've been to: Mobility Field Day, Security Field Day, Black Hat, a lot of things. So definitely go check all that out. Consume all that writing, learn all the things. Then maybe you'll have to go buy an AI ML chipset from one of these vendors to be able to process it, turn it into useful things.
Exactly. I can verify all of that information is true, Tom. So thank you for sharing it. You can find me on Twitter at Mr. Anthropology. That's MR Anthropology. And my writing at gestaltit.com as well. We'll be back next Wednesday at 12:30 p.m. Eastern Time, running down the IT news of the week. Remember, if you ever catch part of this, you want to get maybe just some audio goodness, you don't want to watch the whole video show, we also have a podcast feed for the Gestalt IT Rundown. Just search for Gestalt IT Rundown in your podcatcher of choice. You can find it there. For Tom Hollingsworth, for myself, Rich Stroffolino, for all of us here in the Gestalt IT family, thanks for watching. And remember, everybody, have a super sparkly day.